In our last session, we defined artificial intelligence as the creation of machines that can simulate human intelligence. But how do these machines actually learn to be intelligent? They don't just magically gain knowledge, right? The primary engine between modern AI's ability to learn and adapt is machine learning. This isn't just a buzzword. It's a revolutionary paradigm that allows computers to improve their performance, and particularly on tasks, without being explicitly programmed for every single scenario. Now, we're going to just peel out those layers and see how incredibly the process of machine learning works. Welcome back to my channel, and welcome to Model 2 of this series on AI literacy. My name is Lilian Shulikatata, and I'm going to be taking you through the whole series of AI literacy, machine learning, and eventually we're going to look at AI governance, responsible AI, and ethical AI. Imagine you're training an apprentice chef in a kitchen. We're going to use an analogy to explain this. Traditionally, you're going to give them, a massive cookbook with every single recipe step by step that is very explicitly programmed, right? Or explicitly explained. But with machine learning, it's very different. You give your chef different things. So you're going to give them recipes, one, which are the algorithms they will learn from in machine learning. And these are not complete dishes, but they are rather the methods or the rules for how to learn. I'll give you an example. A recipe might say, try to find ingredients that often appear together, or adjust seasoning based on feedback. The algorithm is the blueprint for how the machine will process the data and discover the pattern. Because your apprentice chef or your learning chef is going to study those recipes and find different patterns in the recipes, such that when you ask them that question, maybe adjust seasoning based on feedback people give you, or maybe find different ingredients that often appear together, they just spit out the response to you. This is the way machine learning works. You don't tell them what to do, you let them learn from the data. They learn the patterns from data you feed into them. Secondly, let's look at the second tool, ingredients, which is the data. So this is just the raw material. The examples that machine learning will learn from, basically. If our chef is learning to identify a perfect chocolate cake, let's go back to our chef. The data would be thousands of images of cakes, some perfect, some burned, maybe some gooey, and along with notes on the quality cake or how it tastes. Now let's talk about the taste buds pattern recognition. So the goal for our chef here is to develop the ability to discern patterns. After seeing so many examples, they just start to notice, cakes with shiny or uncracked tops and a particular smell usually get really bad reviews. And this ability to find relationships, or maybe cakes with a dark side with terrible smells, are usually burnt and bitter cakes, right? And it just gives them the ability to find relationships, correlations, or even anomalies in data. This is what is called pattern recognition. So machine learning is essentially, or basically, giving computers the ability to find these patterns in different or vast amounts of data set and use them to make predictions or decisions. And it improves over time without direct human intervention for every new piece of information. So after they learn those patterns and correlations, each information they receive now, they improve with it over time. So let's look at the distinct or the different process, or this process of learning, right? And this is just basically three different phases. Let's use our apprentice chef again, right? Just like our apprentice chef does not learn overnight. Machine learning model goes through rigorous phases to ensure it learns effectively and performs reliably by giving us best results. Now we'll look at the first phase, which is the training phase, just learning the different ropes here and there. This is where our chef does their bulk of learning, or the machine. In this case, consider the chef as our machine, right? And they are given a large data set of ingredients or data, and are told what the perfect dish is. The perfect dish would be our desired output. So let me take it back. The training phase. This is where our chef does most of the learning, or where the machine does most of the learning. So our chef is given a large data set of ingredients, which for machines we consider data, and they're told what the perfect dish is, which is the desired output, right? And what they look like for each of these. The chef practices making dishes repeatedly, learning from its mistakes and adjusting their technique based on what it observed. Right? On the other side, the machine learning algorithm also adjusts its internal parameters to find the best patterns and relationships within this training data. You see how these two work? Let's look at the next phase, which is the validation phase. And the validation phase is basically refining the technique, right? So after initial training, our chef moves to a smaller, controlled test kitchen. Here, they try out new recipes that they haven't seen before from the main training set. They don't serve these to their customers, right? But they use this just for their own judgment to refine their skills and to make smaller adjustments to their different techniques. This is them just testing themselves, using and trying different recipes from the data that's given them so that they can learn more. Now, this validation data helps us to fine-tune the model. It ensures it's not just memorizing the data, but it's truly learning general principles on the data that is being given. Now, the third phase, the testing phase, right, or the grand open. So finally, after our apprentice chef has gone through the first phase of training and then validating, right? Now we're at the testing phase, and this is where chef comes to prove their skills. They cook dishes for a panel of anonymous critics who provide completely unbiased feedback, recipes the chef never even encountered before during their training or validation, right? So the test data is completely new and unseen. It's providing a true measure of how well the model will perform in the real world with fresh data. And this is a very crucial step, and it tells us how well our model can be generalized, or how well our model can generalize its learning to new unfamiliar situations. After going through the different phases, the testing phase, it basically tells us how much it would learn if we inputted new data. So these are the different types of different phases of the process of which it learns. It goes through training, then validation, and then of course the testing phase. Now the next phase is evaluation, right, where we're looking at the model performance matrix, or we're judging our chef's data. So how do we know that our chef is doing a good job? We need to evaluate their performance using model performance metrics. These are just quantitative measures that tell us how accurate, reliable, or even just how useful learning model is. I'll give you an example. If our chef is learning to spot bad ingredients, what can we measure? We might want to look at things like accuracy. How often did the chef correctly identify whether an ingredient was good or bad? And we give it a percentage, maybe 80%, 95% of the time they did identify if an ingredient was good or bad. Now, the next one is precision. And these are actually the metrics that are used to measure machine learning model performance. When the chef said an ingredient was bad, how often was it actually bad? Right? This is really crucial for avoiding what is called false alarms, because you could say something is bad and wasn't really bad, and it causes a lot of false alarms within your model. So you also want to look for precision. So the next metric we're looking at is recall, right? And basically we're like, out of all the truly bad ingredients, how many did the chef correctly identify as bad? And this is really crucial for not missing the critical issues, right? So, and also choosing the right metric depends on the specific problem you're trying to solve. Medical diagnosis AI, missing a disease, which is low recall, is far worse than a false alarm or low precision. Right? So understanding these different metrics is really vital for correctly interpreting an AI's performance and making informed business decisions. Let's make it more concrete with a simple visualization. Just imagine we're trying to, say, predict how many ice creams will sell based on the temperature of the day. Our data points at this space are what? Temperature and ice cream, or temperature and ice cream sales. Right? Initially, the computer knows nothing. So we feed it historical data. On a degree or on a 20-degree day, we sold maybe 50 ice creams, and on a 25-degree day, we sold 70 ice creams, and so on. These are our training examples, right? Now, the machine learning algorithm starts to draw a line through these points, trying to find a pattern. It's really essential. It's basically guessing, then correcting its guesses based on how far off it was. So over many iterations, the line would learn relationships. Now, when you give it a new temperature it hasn't seen before, it can use this learned line, or you can use this learned line to predict how many ice creams we might sell. The simple line of best fit, this is what it's called. And a line of best fit is a basic example of a machine learning model learning to make predictions from data. It's the same core principle, scaled up dramatically, that just powers complex AI systems. So machine learning is the powerful tool that allows AI to learn from data, to make predictions, and also to improve over time, all without being explicitly coded for every scenario. It's about algorithms finding patterns in data or through training, validation, and testing. So, as we already know, there are three different types of machine learning. We have what is called the supervised learning, we have the unsupervised or the semi-learning, and then we have the reinforcement learning. And we're going to start, or our next deep dive would explain what supervised learning is, which is the most common way, by showing them exactly what the right answers look like. But not all learning is the same. In our next deep dive, we'll explore supervised learning, the most common way to teach an AI chef or our apprentice chef, by showing them exactly what the right answer looks like. If you're ready to discover how AI learns with direct guidance, join me for our next session where we'll dissect supervised learning, complete the real-world examples, and a fascinating case study. Don't forget to like this video and subscribe for more essential insights. And also send this to a friend or someone whom you think can benefit or will learn from this. Again, this is part of a series of AI literacy course. And if you want to learn more, in the form below, enter your email address and I'll be sure to send you more resources your way. Bye, and I'll see you next time.